In this video, I'm just going to show you how I completed the lab or the results of the configurations that I have and how the network is working. So this is one of David's DNS3 lab called DMVPN IPsec and NAT across BGP Internet routers. So we have, let me explain the topology. We have ISP1, ISP2 here, ISP2 and ISP3, and they are all in AES 65000, and we have another ISP4 and ISP5, and they are both in 65001. So these are the tasks that I have, that you have to configure, but I have, already finished the lab, and I'm just going to show you, like I said, the results. So it says here, 1, configure BGP in ISP networks. So basically I just ISP1, where are you? Here. So if I do show IP BGP summary, I have a IBGP neighbor relationships with ISP2 and ISP3 here. So to verify that these are, not sure if you can check here. So to verify that, for example, ISP2 is a BGP neighbor, you can just do show IP BGP neighbor and then the IP address. So it says here internal link, right? So that's a IBGP neighbor relationship. And same as other ISPs like ISP2 and ISP3. And if I go to ISP2 here, ISP2 here, OSPF is also configured. Interface brief. So in this case, OSPF is enabled on this interface, gig 0/1 and gig 0/0, which is the interface going to ISP1. So there is a IGP connectivity between the ISPs, at least the ISPs within the same AES number. You cannot make BGP work unless you have IGP running, right? So if I do show IP OSPF neighbors, you see that I have a neighbor relationship with ISP3 and ISP1. All right, so task 1 is okay. So create. And by the way, before I move to task 2, let me show you ISP4 as well. ISP4 here. ISP4. Let me see if I have. So in this case, we don't have OSPF neighbor relationships with ISP5. So we have, looks like we have just a BGP relationship with neighbor relationship with ISP5. So if I do show IP BGP summary, do that again. So 8.8.5.2 is ISP5 and 8.8.7.2 is ISP1 here, or ISP2. All right. What else do we have to verify in the ISP networks? I think that's it. Task 2 is create a DHCP pool on the customer routers to allocate IP addresses in the Ubuntu clients. A DNS server is configured on ISP2 with IP address 8.8.8.8. So let us check that one on ISP2. Begin 8.8.8. Alright, so it looks like 8.8 is the secondary IP address configured on I think that this would be gig 0/0. Yeah, so this is the IP address, the secondary IP address on gig 0/0. So that's what the DNS server in this case. ISP2. Turn into a show run. Show run here. Here, so Cisco. This is actually the host here on top, Cisco, right? IP host cisco.com. Here, I think this is, I'm not really sure how to configure DNS server. I have to check myself, but this is what I see on ISP2, because in this scenario, ISP2 is the DNS server, right? So you have to double check on how to configure a router as a DNS server. Yeah. So task 3, configure full mesh DMVPN tunnels with C1 as the hub site. So C1 is our hub site. Use GRE without encryption first. So what is this saying is on C1, if you do a show run, so here this is phase 1. This is phase 1, and this is phase 2, and this is how you apply the profile, which is in this case we are creating a profile Cisco named Cisco, and we applied the transform set, my set, and then we are applying it on this interface tunnel 111, the crypto profile or the IPsec profile here. We are applying it here. So tunnel protection IPsec profile. So it's just saying that you don't have to apply the profile, the IPsec profile first. You can just go ahead and configure full mesh VPN tunnels with C1 as the hub site. So that's actually what I did, and that's what David Bombal showed as well. And task 4, enable NAT on the customer routers so that the Ubuntu hosts can access cisco.com. So let me show you the configuration of the NAT. So on C1, for example, our NAT outside, IP NAT outside is this, because this is the interface facing the internet in this case here, and this interface is IP NAT inside because this is facing the LAN network, right? And our IP NAT configuration is this, IP NAT inside. While I was doing this lab, I actually missed configuring inside, and I had a problem with that. So inside is important, so you have to be careful that you add inside, just because you can also say, let me just paste it here. You can also say IPNet source without adding the parameter inside. So that's what I missed, and I was having a problem. So that's one of the lessons that I learned. So you have to enable NAT on all the customer routers, so C1, C2, C3, and C4. So they have, I believe they have the same, almost the same configuration. Actually, same configuration, because they are all using gig 0/1 as their WAN facing interface, and gig 0/0 as their LAN facing interfaces. Yeah. And so basically this is, IPNAT inside source list 1 is the access list, permit any interface. So that's how you configure NAT. And of course you have to, I think it doesn't say here, that you have to configure IP route pointing to the ISP, right? So for example, on C1, it's got a IP route, default route pointing to 8.8.3.1, and same, you have to do the same for all the customer routers. And 4 is enable NAT. So this is, so that's what I just explained. And 5, verify that Ubuntu PCs can ping cisco.com. So let me go to Ubuntu One and ping cisco.com. Of course, this is going to work because I tested this before, and this is going to work on all the Ubuntu hosts. Ubuntu host 2. Cisco, Ubuntu host 3, ping cisco.com. Okay, Ubuntu host, Ubuntu 4, ping cisco.com. Right. All Ubuntu hosts are able to ping cisco.com. So task 4 is completed or verified. Verify the Ubuntu PCs can ping. No, this is task 5. So verify that Ubuntu PCs can ping cisco.com. So that's done. Verify that Ubuntu PCs can ping each other using. Okay. So I'm going to Ubuntu 1 and I'm gonna do ifconfig. It's got this IP address, and Ubuntu 2. What's the IP address of Ubuntu 2? It's got an IP address of this. So I'm going to ping Ubuntu 2. Okay, that's working. Ubuntu 3. That's also working. And Ubuntu 4. So we only have 4 Ubuntu PCs or hosts, right? So Ubuntu 1, Ubuntu 2, Ubuntu 3, and Ubuntu 4. And 7, this is how you enable, like I was explaining earlier, or apply the IPsec profile on the tunnel interface. So let me go back to C1 and show you the config. This is task 7, enable IPsec encryption for DMVPN tunnels. That's talking about this, or all these configurations. So IPsec, phase 1, phase 2, applying the transform set under crypto IPsec profile, and applying the IPsec profile Cisco on the interface itself here. Alright, verification. Verify connectivity between Ubuntu PCs. So we've done that already. Verify that packets are being encrypted. So this is something that we have not done yet. Verify that Ubuntu PCs can still ping Cisco. I'm gonna do verify that packets are being encrypted. I'm gonna do that last. So I'm gonna, of course we can still ping Cisco, right? Yeah, that's still working. Cisco.com. Yeah, it's working. Of course it's working. So yeah, I'm gonna go and capture traffic here. Start capture. So C1 0 gig 01 to ISP4 gig 00 /0. Okay. So I hope you can see the tasks clearly, because it's a little small. It's a little bit small. Let's just wait for that traffic capture to pop up. Okay. And while that's running, I'm actually going to show you that. So, of course, we have this. I have this configuration. This is created by David Bombal. So this is the configuration, DMVPN configuration for the hub site or hub router, and this is the configuration for the spoke sites or spoke routers. So what I did, I actually just copy and paste, this configuration on C1, and so in this case, C2 has this, IP address. So 192.168.1.2.c2.3 is C3 and .4 is C4. So okay. So as you can see, we are seeing a lot of ESP protocol. Let me go and ping cisco.com and filter for icnp. So you can actually see the ping because that traffic is not being encrypted, or that's not passing through the tunnel. But so you can see here that, where's that again? Yeah. Oops. So in this case, source IP is 8.8.3.2 and destination is 8.8.4.8, and that would be this, this Cisco host. Let me just make the font a little bigger. So config. So yeah, that will be that IP address here. But here we don't see the 10 IP address, right? We only see the public IP address. Let me also ping one of the hosts, say Ubuntu 4, and go back to here. So a lot of ESP packets. Reduce ICMP. I'm not seeing 10 IP address. ESP. Yeah. We should see BGP here. No, because C1 doesn't have a BGP neighbor relationship with ISP4, right? So it's just a default route. Do ICMP again. ICMP. I need to be more familiar using Wireshark, but as you can see, there's no 10 IP address series, so it's all the we can only see the public IP addresses. And let me stop that and go to C1, and there is couple of commands that you can use. So show, this is the connection to what is this, C3, this, and this is C2, and this is C4. So here, so these are the one facing IP addresses, and of course this is the private IP addresses. So they are all dynamic attributes. Let me show you. No, let me do crypto SFM. That's it. So this should be the state QM that you should see. And IPsec. So traffic is incrementing here. It should be incrementing. Let me go to Ubuntu C2 and show you this. So this is the connection, the tunnel connection going to the hub, right? The C1, and it says static. And the connection to, what is this? C2, we are on C2, right? And the connection to C3 is this. It says dynamic. Let me do show. Now it's showing static. So when the tunnel is not being used from C2 to C3, the tunnel gets terminated in some point. I'm not sure how long. I need to check on that as well. But that's how you can tell that whether the connection is static or dynamic. So in this case, the connection going to hub is static, but the connection going to other spoke sites are dynamic. So let me say that again. The connection going to the hub is static, and the connection going to the other spoke sites are dynamic. So I think we're done. We have performed all the tasks. So yeah, this is, like I said, from David Bombal, created by David Bombal, and this is his site. Okay. Alright, so yeah, that's it in this video. If you enjoyed watching this video, don't forget to drop a like and subscribe, and I'll see you on the next one.